Hey guys, Mr. Holly here. Just felt like we needed to make one more final video to post online just to kind of put an exclamation point on this year. Um, but you have a test coming up on exponent rules, and it's going to be a significant portion of your grade. So I figured it would be nice to just give you a nice review. This is in your packet. It's page 5. Like if you turn 3 pages in, you should see it. I already have mine complete. I just want to talk you through this review, and then I'm going to encourage you to use this review on the test that you take. So I don't know if you've been real strict about not using materials or using materials while you've been testing, but I want to encourage you to use this as you do this test tomorrow. I will also say the test has to be done by tomorrow because all grades will be final on Monday. So it needs to be done this weekend. Okay, let's start with our first rule that you learned about. That rule is the product rule. And that rule says that if I have the same base, any two numbers with the same base, if I multiply those together, I can add the exponents. In this case, x to the a times x to the b would just be x to the a plus b. If you look over here, you've got h squared times h to the sixth. If you expand that out, that's h times h, or h squared, multiplied times h, 6 h's being multiplied together. So in essence, what's happening is we're multiplying 2 h's together and 6 h's together, and we end up with h multiplied times itself 8 times, h to the 8th power. Down here you have a second example, and I think it's important to identify all the factors that are present in this problem. So in this problem, you have 6 different factors that are being multiplied together. -2, a squared, b, 7, a to the third, and b. So because multiplication is commutative and I can move those around, I'm going to order those together in ways where the like bases will be multiplied together. So -2 and 7 are going to be multiplied together. They're not like bases, but they're both numbers that can be multiplied together and simplified. A squared and a to the third power, those are like bases, so I'm able to multiply those together and write that in a more simplified version. And b times b, I can multiply those together and write that as b squared. So my answer is -14, a to the fifth, b squared. All right, the next rule is the power rule. And this is the idea that if I have some exponent, something written in exponential form, and then I raise that to a power, what I'm doing is multiplying the exponents. And I can demonstrate that through expansion here on example 1, x squared to the third power. That would be like x squared being multiplied times itself 3 times. X squared times x squared times x squared. And then if we kind of bring that back to the product rule, that means I would just add up these exponents. 2 plus 2 plus 2 would be x to the sixth. So what's happening here is I have x to the second power 3 times, which gives me x to the sixth power. You multiply the exponents. If I look down here at the second example, I have -2m to the fifth, all raised to the second power. It's important to realize that these are separate factors. -2 is its own factor. That's its own base. It needs to be treated as such, so that will be raised to the second power, as well as m to the fifth is also going to be raised to the second power. So it would be like -2 squared and m to the fifth squared, which is m to the 10th. So then I multiply here times m to the third, 4m to the 13th. I want to expand this over here just so you can see it. -2m to the fifth is like -2m to the fifth times -2m to the fifth. So you would say that's -2 times -2 times m to the fifth times m to the fifth, right? And that's where you get -2 times -2, or -2 squared is a +4. M to the fifth times m to the fifth, that's m to the 10th. And then remember you have this m to the third power here as well. All right, let's look at the quotient rule. Any two numbers in exponential form, when they have the same base, I'm able to subtract the exponents. So if I come over here and look at example 1, I've got 27x to the fifth and 42x to the first. So let's not worry about the integers just yet. Let's just look at the x, at the variable terms here, or excuse me, the variable factor. It is x to the 5th and x to the 1st. So 5 minus 1, I get x to the 4th power. You could also think about that as I have x being multiplied times itself 5 times in the numerator, and I have 1x in the denominator. So these are going to cancel. X divided by x creates 1, and I'm just left with x to the 4th power up here. Okay, these are all being multiplied together. All right, we just simplify this fraction. 27/42 is 9/14. Y squared to the 2nd power, that's the power rule. 2 times 2 is 4, so y to the 4th over y to the 4th. Anything divided by itself is just 1. We also see if we were to use the quotient rule, 4 minus 4 is y to the 0. That kind of brings us down. Let's go all the way to the bottom, and we'll do the 0 power. Anything raised to the 0 power is just going to be 1. So in this first example, we have 7 times x to the 0. All my in-person students really got tripped up by this question. I said, well, what is it? And they said, the answer is 1. I said, no, guys, look, there's 2 factors here. 7 times x to the 0. That means x to the 0, yes, that is 1 because it's to the 0 power. But remember, these are 2 separate factors. So now I'm doing 7 times 1, and I get 7. And then number 2, w to the 4th power squared. It gives me w to the 8th divided by w to the 8th. That's w to the 0 or 1. All right, let's talk about negative exponents real quick. I'm not sure how the videos necessarily portray these to you as you're being taught, but one of the ways I like to think about negative exponents is as the inverse operation. So positive exponents tell me that I am multiplying by a certain number this many times. So 2 to the 3rd power means 2 times 2 times 2. 2 to the negative 3rd power tells me I'm doing the inverse operation of multiplication. It's not a negative number. It's the opposite operation. It's the inverse of multiplying. That's what that negative tells me. So instead of multiplying by 2 3 times, I'm dividing by 2 3 times. So instead of having like 2 to the 3rd power, I would instead just be dividing by 2 to the 3rd power. So instead of being in the numerator, it goes in the denominator because it is repeated division. When I see that negative exponent, that's the way it really makes sense to me, is to think about it as dividing multiple times. All right, so negative 5 times x to the negative 2. Again, remember, these are 2 separate factors. Negative 5 is its own thing. It stays. We're multiplying by negative 5. It goes in the numerator. We're multiplying by that. We are dividing by x squared. X to the negative 2 means we are dividing by x twice. So x squared would go in the numerator. A negative exponent becomes positive by putting it in the denominator. All right, and number 2, the last one we'll do here, 4k squared divided by 8k to the 5th. We can simplify this to 1/2. 4 over 8 is 1/2. K squared divided by k to the 5th. When I do that, I get 2 minus 5. That's negative 3. So k to the negative 3 means I'm going to be dividing by k to the 3rd power. Dividing by k, dividing by k, dividing by k. So I can say that this is divided by k to the 3rd power. I can also look at it as just kind of simplifying, expand this out, simplify it down. 4 times k squared, that's k times k. K to the 5th, that's k, 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 k. Okay, so if I cancel out 2 k's from the numerator and 2 k's from the denominator, because I'm just eliminating those factors, just canceling those out, I'm left with k to the 3rd power. All right. A couple other quick thoughts with exponents. A couple things you need to know to make sure we don't slip up. Anytime you see a negative integer raised to a power like negative 2, if the negative sign is inside the parentheses, that means that it is included with the number. It is part of the base, and it should be, like when you multiply, it would be negative 2 times negative 2, which gives you a positive 4. Anytime you see a negative sign and it is not inside parentheses, then it is not included with the base. This would just be the opposite of 2 squared. So you would do 2 squared, which is 4, and then take the opposite. These are going to give you different answers, and it's important to make sure that there are parentheses whenever you're looking at exponential form with negative integers. Another thing that will probably come up, if you have an even exponent, will you get a positive value or a negative value? If you have an odd exponent, will you get a positive value or a negative value? And the way you need to think about this is if I have a negative number and I'm multiplying an even number of times, a negative times 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 a negative, these negatives combine to make a positive. These negatives combine to make a positive. These negatives combine to make a positive. And therefore, I just have positive. The whole thing is going to be positive. So anytime I have an even number of negatives, it becomes positive. And if I have an odd number of negatives, it would then be negative. So like if I multiply this by one more negative, now we've got a negative number. Okay, so even number of exponent, positive. Odd number exponent, negative. All right, guys. Hope that helps. Good luck with your tests. Thanks for hanging in there with everything this year. Thanks for being patient with me. I hope you guys have success in this test and it helps your grade. Thank you.